Everyone, and welcome. My name is Gary Hicks, a name somewhat known around the water well industry. Some of you may remember 2019, I was the McElhenney Lecturer for the NGWA. But today I'm here to make a presentation to the Washington State Groundwater Association. And the subject that I've chosen is multiple uses of dual rotary drill rigs. Let me explain. I'm not a salesman for Foremost dual rotary drill rigs. I'm a strong advocate for the use of them. I'm no longer a water well drilling contractor who owns one of them, but I've been an advocate and I've had a strong interest in the DR methods for quite a few years. And I've had a number of opportunities to make a similar presentation to groups of people who were not familiar with this drilling method. So let me begin by saying, since about 1991, I wrote an article for the Water Well Journal about what was then called the Barber drill. It was the same company that's now owned by Foremost, but they'd been making drill rigs in Calgary, Canada for a number of years. The fellow in the middle of the photograph on the right is named Julius Mackey, and he used to personally come out and oversee the operation, the first time operation of every drill rig that left the factory. Things have changed a little bit since 1991, but they're still doing things out of that same factory location. And that's where you get a Foremost DR drill rig today. I also had the opportunity to write about a dual rotary drill rig that I was responsible for. I was the licensed drilling contractor and the qualifying party for a environmental drilling services business in Scottsdale, Arizona in the early 1990s. And at that time, I wrote this article about the necessity to keep drill rigs clean, especially when doing environmental work. And I wrote this article called Squeaky Clean Drill Rigs and about some of the do's and don'ts while you're pressure washing or steam washing these pieces of equipment. But this was the DR12 that I was promoting at that time. Now, there's two basic models of the Foremost DR rigs today, the DR12 and the DR24. And what the two numbers identify is that the inches in diameter, the maximum inches in diameter that particular drill rig can handle. Now, this was an earlier model DR12 with an onboard air compressor. I believe that was a 750-250 at that time. And it's shown here where we were drilling at a power plant in the Arizona area. And you can see the cyclone on the side of the drill rig. And we were at that time just drilling dry and letting the cuttings fall onto the piece of plastic there at the time. This was not an environmental drilling project at that time, but it shows you what the drill rigs look like. Another job that we did with that particular rig was a little bit different. It was in a landfill, and it did have environmental considerations, hence the need for PVC suits and respirators at the time. At this time, we were advancing 12-inch ID casing to a few hundred feet in order to make a groundwater remediation well. Inside that 12-inch casing, we built an 8-inch diameter stainless steel wire wrap screen remediation well. What we learned, and I learned certainly at that time, when you're trying to advance steel casing 12 inches and larger, and using the conventional 4.5-inch diameter drill pipe, the air requirement, uphole air requirement for removing the cuttings with those two dimensions is, well, demanding, to say the least. So in addition to the high pressure air on board with the drill rig, I had to bring in one unit of a 700-200 CFM air compressor, low pressure air compressor. Once we got the circulation started, then I would tag in the other air compressor to get the necessary uphole velocity for executing the well drilling in that manner. But things have changed since then, and I'm going to show you later on some examples of how that's simply no longer a problem and no longer requires the additional air compressor. Now, the first thing to understand about a dual rotary drill rig is that there are two rotary drawworks. The upper conventional, more or less conventional drive, top head drive system, and then the lower drive system and motor that rotates the different diameter steel casings. In this photo here, you can see that it's set up to maybe advance only 6-inch diameter casing. But there's two motors, two controls, two up and downs, two left and right, and two rotating speed handles for the driller to master. But independent casing advancement, in addition to the top head drive, you can drill a little bit out in front of the casing, or you can drill up inside of it. And drill rigs like these handle multiple casing diameters. And the thing that I liked about it as a geologist was the excellent soil sample or cuttings recovery that I could get to identify exactly what we were drilling. In this photograph, young David Marr was fastening the bolts that tie the 12-inch diameter casing to what was called a diverter at that time. You can see that he has his arms around the diverter discharge pipe, tightening the lug nuts that hold the 12-inch casing in there. He's standing on the lower drive table. This is the motor and this is the drive table while doing that, because the top head drive of this equipment tilts out at an angle so that it can pick up the drill pipe and the casing all at one time. What we might notice here on this older style rig was that what holds this diverter on top of the casing once they're in place and separated, because the top head drive will be turning the drill rods and this will be not be turning the diverter. It's stationary and it rotates in this area, but there's simply two chains that hung down onto studs on the top of that diverter in order to hold it in place while the casing was picked up. But I'll show you later how that's been changed and improved. Some of the advantages of the dual rotary drilling rig is that it can line the borehole with the casing as it drills. You're typically rotating to the left with the casing while turning to the right. And because you're lining the wet borehole as you go, there's little chance of lost circulation or caving problems in the well. And also it tends to keep it pretty plumb. You can drill through soft sands to hard boulders and so on. There, I'll show you some of the equipment that used to drill the harder rocks. Can utilize a telescoping screen well design with a drill rig like this. That means you can put in a slightly smaller screen diameter and extend it out the bottom of the casing, or plant it on the bottom of the casing advance and then pull back the casing to expose the screens. We call that the telescoping well screen design. It uses regular line pipe casing sizes, the standard API sizes of 6 through 24-inch diameter, with one exception that we found out about one time, was that if you're trying to use Roscoe Moss blank casing and that, we found out that that is a slightly different OD diameter of the other line pipe casings, and that causes some modifications in some of the pieces of equipment to handle that one. But various diameter wells can be drilled and made with one drill rig, and it's a fairly small footprint that this drill rig has. And the other thing that truly is an advantage, it minimizes any impact on nearby pumping wells or other terrain issues. If you look here on this photograph, this is the time when we were developing and pump testing a brand new 18-inch wire wrap screen well inside 20-inch diameter advanced steel casing, drilling that well while right next door to this well. Now, at the time we were pumping here, drilling, this one was not pumping, but all the wells on this 17-well project were drilled within 20 to 30 feet or less of an existing well, not something that you'd look forward to doing with any open borehole drilling method. But with the DR method, there's certainly no problems. And I know we have on several occasions drilled and advanced casings in distances similar to this on wells that were still kept in the pumping condition. They would just be turned on when we weren't actually drilling, just for safety reasons, and turned off, you know, but you could have it in operation while you're drilling the replacement well. That is a big advantage. And also the fact that you can do that. You can have the replacement well installed and working before you abandon the old well. That's a definite advantage of this method. I like this photograph. We were about to advance 24-inch diameter steel casing. This is the cutting edge shoe called the ring bit with the tungsten carbide inserts in it, inside 24-inch diameter half-inch wall casing. And over here on the one behind me, I can see the 7.5-inch dual wall pipe. That pipe is what we now use to drill reverse circulation while advancing large diameter casings. You can advance steel casings much larger diameter, with much less compressed air. Typically the rigs are coming with a 950 CFM 350 PSI compressor, and that's all you need to advance 24-inch casing if you equip the rig with this 7-inch diameter, typically dual wall pipe. And here's how that is used. The illustration on the right shows the downhole hammer being advanced inside the casing, and as the air for the drilling exits the bottom of the hammer, it starts up the casing, but because we've closed off the casing with closing that diverter at the top of it, and with this crossover sub that's mounted just above the hammer, the only place the air and the cuttings can exit the inside that steel casing is up the inside of that dual wall pipe. And that is what gets you really low requirements for compressed air and very good samples, because any sample that you've drilled comes from this area just a few inches up inside the casing. That's typically where you keep them matched up. But it's always cleaning out the well as you go. So whatever comes up and out of the cyclone, as I'm being shown here, sampling at the cyclone, catching the samples that cut out of it, it is exactly everything and only anything that can come in from the bottom of the casing. So as a geologist, I think you know the character of the material, and you can even do some checks of the quality of the water with a well like this. You can have it sampled for the inorganic constituents. So drilling with a dual wall pipe, reverse circulation flow, and a cyclone like this delivers the cuttings to your hand or to your sieve or whatever, just as gentle as can be. And it really also, while you're doing this, provides a good estimate of the productivity of the aquifer. And as I've already mentioned, you can take water samples while drilling with this method. Now here's the secret to it: the dual wall pipe that's matchable to everything on the rig, and the little collar piece, the slip joint that goes in between each tool joint, each rod, drill pipe, as you put it together and going in and coming out. That's what really makes it work. Now I'm going to show you some examples of just how effective that can be. On this particular project, we were advancing the 24-inch diameter casing to make an 18-inch diameter stainless steel well by drilling on top of an artificial berm. This is not normally compacted soil. This is man-made material with of some elevation. You see, in this case, it's only a few feet, but this is not an area where you would just start off in the land surface with an open borehole drilling. But we set up on this particular berm, which was pretty narrow, lined it with some plastic to keep from washing away the bank, and started drilling and advancing the 24-inch casing. And I was collecting samples all the way through that to know what we're doing. The end result of that drilling project was this injection extraction well that was installed inside the casing, there were 3 pipes for injection and 1 pipe for extraction. So this was an injection extraction well all in one place. This is the 20-inch diameter casing, and it was a telescoping screen design of the 18-inch wire wrap screen that we put in. There's some pictures of that. You can see that in starting that job, we just simply advanced the 24-inch diameter casing right from the very top of the berm. That's the way that we began that well. And typically when we're doing something like this, I'm going to a general example now, is we can set a large diameter surface casing and then advance a smaller diameter casing down through that larger one and advance it to whatever depth is required or necessary, or you get the water quality or quantity that you want, and then put in a telescoping screen design. This little illustration shows you how we go about doing that. Up here on the surface is the temporary surface casing that we can set in, even to a depth of 50 feet as required in some places in California. Advance a 12-inch diameter casing in this case, and then once that's advanced to the total depth that you want, you can install 20, 40, 60, whatever feet of say 8 by 10 pre-packed wire wrap screen. Well, what Johnson calls the Johnson Munipack. And this is kind of an example of how that works. Here's the drill bit drive shoe casing, ring bit case bit that's on the advanced casing, the wire wrap screen inside, and the K-packer is simulated there. So that's how that works with any different size that you want, from 20 installing 18 in 24, or 6-inch inside 8-inch casing. A lot of different options, all with one drill rig. This is the Johnson Munipack that we put in a number of times using this method, and it works quite well. The phenomena that we use with the temporary installation of the surface casing is, in order to get the cement grout seal required for, say, public supply wells or wells of that where drinking water, then you can fill this full of cement and extract that casing, fill it full of cement, extract some casing, fill it full of cement, extract. So you can get a perfect grout seal to a depth of whatever you've set the temporary casing, and then you're just leaving it as a 12-inch case well. Or if you want, as we did in the extraction injection well, we left a short piece of this outer temporary casing in place within the cement, and the pumps and the injection pipes were hung on that well. This is the Johnson Munipack that works quite well with this method. What I'm showing you here is how we install and let go of the telescoping screen well when it's way down there in the well at some depth. We use a special little custom-made gadget like this that's welded to the top of the string of casing that you're going to run. This is just a sub that I've set on there to show you the drill pipe connection. And you can see the 3 lugs cut into the outer casing that we use to grip and hold on to that while it's going into the well. And as it's going in, we also wrap the tape around it to sort of keep it clean and neat in there. But here's the K-packer going through the larger casing as it's being installed from the top surface going down. So you just lower that all the way down to the depth that it's going to be set to, and then turn to the left just a little bit, and that lets go of it, and you pull back. Then immediately as you pull back, since you just have basically an open pipe with a stud on it, you can begin to reverse circulate, develop this well. Again, the advantage with these rigs is if you use the reverse circulation drill pipe, you can pump wells. You're not blowing the well out and blowing air and oxygen into the formation and trying to develop the well with submergence ratio, but rather you're doing it reverse circulation from the bottom up. And that develops up the well very clean, very neat, and also gives you an idea of the productivity of it while you're doing that. An alternative method to the telescoping screen well design that we've used on numerous occasions for, say, irrigation wells, and this is a case of drilling a new irrigation well within a certain distance of an existing irrigation well and as a replacement well, but we call it the perforating in place design of the well. This is when we use a special tool, as shown here. There's the cutting wheel that does the perforations as we advance that down the well and decide, you know, because you've collected samples through the cyclone while doing this drilling, you know exactly which zones you want to perforate, and then you can leave the other zones blank. But it's a very effective way to make a less expensive well than using stainless steel screen by perforating in place. Now, some of you may be familiar with what they call the acoustical televiewer logging method. If not, I'm going to explain a little bit of it too. I'm not going to go into much of the first section of this graph right here, but you can see the depths that we were working at in this well. And what's represented here in the yellow background with the blackish dots on it, this represents a 360-degree inside view of the casing, made using sound. And that shows you where the perforations are and where the blanks are. Now, in the smaller column to the right is a picture like created by the computer of the outside of the casing that we've perforated and where the perfs are and where the blanks are. And in the little blue line graph on the right, it shows the extent of the sound, how far out into the formation the sound waves traveled while making this geophysical log. So this is an excellent way. It's not always necessary, but if you do want to know what your perforations look like after performing, the acoustical televiewer log is an excellent way to do that. Of course, you can also use a video camera log to do the same thing. Now I'm going to show you what's unique about the DR rigs and the tilting top head that has to pick up the casing. This is back to drilling that injection extraction well that we drilled on top of the berm. Here we're picking up the 24-inch diameter casing. The geologist is looking at saying, oh my goodness, look at all the mass of weight that's being picked up there. And it is pretty impressive when you see the size of bit that you can pick up and handle with a standard top head drive drill rig, basically, and start advancing a 24-inch diameter casing with just a single 950, 350 air compressor. Very impressive. In making that well, this slide shows you the retention ponds that were part of this extraction injection well that we were doing. It was at a wastewater treatment plant where they wanted to store reclaimed water underground. In the desert Southwest, we do have a problem with evaporation, and so that's trying to store water in above ground ponds isn't so cost effective as it is putting it in underground and storing it underground. So here's the 18-inch diameter stainless steel wire wrap casing and three blank stainless steel shafts. There was more on there. This is just what I put in this one. And you can see us in this case here, we were loading the wire wrap screen on that one, putting it into place, welding it together, lowering it down until you get all of the casing in place. This is the guys loading up the 18-inch blank casing. And you can see that the berm was not very wide. This is kind of like working on a wall where everything had to come in and go out in a very narrow path. You can drill with a DR rig using a downhole hammer. On this left-hand slide was a 12-inch diameter hammer with a 19-inch diameter bit that we used to drill a number of wells while advancing 20 and 24-inch casing. The crossover sub that I spoke about earlier that's just above the hammer is shown here. as the driller was taking a look at and poking at some of the rocks in it. And then I can see the bottom end of that stabilizer that we typically use when putting that down inside a large diameter casing. But all the cuttings and material and all the air and all the water and everything come in from two sides of this crossover sub and go up the center of that dual wall pipe. But it doesn't have to all be large diameter casing. Here's a few slides I wanted to show you of advancing. On the left here, just 6-inch diameter casing with about a 5.5-inch diameter studded carbide tungsten bit, and making a small diameter well. In this case, I believe it was a monitor well. We were using 6-inch casing and then installing 4-inch PVC casing, probably flush wall, inside this. But you can see that it's very neat, very tidy, and when you drive away, there's just the bit of the casing left behind that you initially advanced. And then here's, it shows that from the foremost material, there's how you could advance the casing down, plant it into bedrock, and from there on, just simply drill open borehole. That's in areas where you're drilling through glacial till and you get to bedrock. The DR rig is an excellent rig for doing that. If you do need to take the casing on down a bit further and you're in relatively hard rock, we've used these opening up bits, under-reaming bits that open up to help preserve the ring bit on the casing and make it easier to get to a greater depth with the casing, with a single ring bit. There's really a pretty small footprint that the DR rigs make, because everything is right there on just the drill rig, and you can get into some pretty close quarters from time to time with it, as long as you can handle the pipe and pick up the drill rods. I'll come back to that in a minute with some other examples. But I wanted to show you this one. This is a very unusual thing, and it takes advantage of one of the biggest advantage things of the DR rigs. I call them a steel pipe planting machine. They are excellent at planting steel pipe in the ground. And if you don't have to bring it back out again, that's even better. But this is a scene of a portion of Lake Mojave. I'm sorry, yes, Lake Mojave, Lake Havasu, I'm sorry, Lake Havasu, near Lake Havasu City, Arizona, on the lake, also on the Colorado River. The purpose here was to plant some casing in the ground. The general contractor put in a cofferdam, pumped out the water, and gave us an area to work in. Can you see, I'm sorry, can you see in the circle here a number of red flags that show where they wanted casing planted? And over here on the other side are some other flags in areas where they also wanted some stainless steel casing planted using the DR method. On the shot on the slide on the left-hand side, you can see, looking down over the top of a string of the stainless steel casings that we planted in a perfectly straight line at very exact distances. And on the slide on the right, you can see the reason why they had to be exactly plumb and in precise locations, because they had to fit a pre-manufactured dock, a floating dock that was going to be in this marina that they were building by holding back the lake a bit. So, and by the time we finished with it, there's quite a few stainless steel 6-inch diameter casings planted in the ground in precise locations in order to build the dock while they had to continue pumping. This slide shows another string of the stainless steel casings planted in the ground exactly where they needed them. And then this was the ramp after it had been poured, but they still had not breached the cofferdam and let the water in yet. I was able to get one picture after a partial breach of the cofferdam, and the water had come in and floated the docks, and I can see them here. I could also see that this is the ramp for the boats to be launched, but the rest of the work had not been finished as far as the paving. I'll have to go back there someday and take another photograph of how that project turned out. But it was very interesting, and it did take advantage of the best aspect of the DR rig, and that is to plant steel pipe vertically in the ground. There's other things that it can do too. For instance, we had an opportunity on a couple of occasions to deepen existing wells. This particular one began with, I think, about a 14-inch diameter steel cased well that was already 800 foot deep. But it was carrying a lot of arsenic for a public water supply. So they asked us to see if we could deepen this well. So deepening an existing well, provided it's plumb enough, is quite feasible with a DR rig. We first milled out the bottom plate on the bottom of the old well, and then once the plate was gone, then we just put the ring bit on 8-inch diameter casing and lowered it down to 800 feet and began advancing out the bottom of the existing well. And you'd be surprised what you can pump and get out of the bottom of an existing well. A lot of material came out of that well as we cleaned it out before we took it on down deeper. It's one of the other advantages, I'll say, of having advancing casing. You don't have to ruin the existing well to make it deeper. You can also just simply use a DR rig for air rotary drilling. You don't have to advance casing. It's a perfectly fine top head drive air rotary drill rig. You can set a temporary surface casing if you want, and then drill open hole in hard rock below it. So there's no limitation on, this is a combination drill rig, casing advancement, air rotary, and mud rotary as shown here. This is the DR12 rig that I was running back some years ago, where we mounted, I think it was a 5x8 mud pump on the deck of this PTO driven DR rig, and ran it with a compressed air to operate the mud pump, and then we drilled mud rotary with it. And that was how we used that one at the time. But if you are a mud rotary driller and you're just extending the capability, you have a rig that you could use your own mud package to drill, and using this drill rig in lieu of a conventional mud rotary drill rig. You can see it's a multi-purpose rig. Here's another example of a well that we worked on, shown here in the foreground in the circle. This was a well rehabilitation tool. Because you're working with it in the reverse circulation mode and discharging through a hose in a cyclone, it's a very good rig for cleaning out wells to bottom and cleaning them out, and then going in there with your chemicals, your disinfectant and your acids and so on, and working those things in place with the brushes and so on, and then airlift developing it from the inside out. In other words, you're pumping the well because you're doing it reverse circ rather than trying to empty out the well from just by blowing compressed air down there. Those two things together give this type of equipment a distinct advantage. Plenty of power to rotate casing in these rigs. The lower drive table has the ability to, I'll go to the manufacturer for the actual torque capabilities, but if you get a little too aggressive with turning probably 6-inch quarter wall, you can end up with something like this. This happened on a couple occasions when the 6-inch wanted to bind up, and you keep turning with the lower drive, you simply wind up 6-inch diameter steel casing to where it looks like licorice sticks. But it's all recoverable, and you can pull it out and go on back and free it up and do it again. It's not the end of the world by any means. Over the years, I worked a long time behind this drill rig as a geologist consulting to this well drilling contractor. But in just September of this year, in the year 2020, the contractor decided that he wanted to upgrade, so he sold this drill rig. It actually went to Chile and replaced it with a brand new 2019 model. And it arrived earlier this year, and we began to put it to work right away. Here, one of the first jobs that we did with it was to advance 20-inch diameter steel casing to a couple of 100 feet. It was also at a reclaimed water plant. They wanted to do some injecting there, but you can see the equipment's all lined up alongside. So this is what it takes: the drill rig, a welder, toolbox, a service truck, a horse trough, usually in order to catch and hold some water where you might, to pump out of while you're injecting water. And you'll have to have a trailer, not shown here, to haul the drill pipe in. The drill rig now, a modern drill rig, is a little bit different from the older ones. I recognized a lot of changes right away when I saw that the dual control mechanisms that they have, the number of levers that this rig has on it. There's this bank of them down here, from everything from the sand line to the jacks to back to lift it up. And but the lower drive, upper drive, up and down, left and right, air back pressure on the air compressor, and a lot of other tools. But it just takes a little while for the driller to get used to using different control levers than what he had from the first one. But one of the features that became apparent right away was an improvement in the ability to hold on to the diverter with a hydraulic clamping unit that's installed on this rig. It grabs onto a ring that goes around the top of the diverter, and instead of that chain that just simply hooked onto it and then while they picked it up, this is a much more secure method to clamp onto the diverter when you need it to pick up the large diameter casing, and then open it up after you've put it in place, to raise and lower your drill string, because this is the top head drive of the drill rig, and it's being used to supply the pipe to the lower drive. But here they're using it, and I can see that this diverter is shut off a little beyond here, and the hose for the cuttings is coming out on the in the swivel from the dual rotary drive. Yes, I can see here where the diverter that would normally let the air come out of the casing is being plugged off. So we're advancing 24-inch diameter casing to some depth, and pick it up and look like, so you pick it up with that, you set it down in place, and then you start to weld them together on 24-inch diameter casing, nearly half-inch wall on a lot of it. It takes about 3 passes. So the driller usually does the welding, and the helper does the grinding. You grind the slag off each weld, and then do another pass, and so on. But while you're welding, there isn't an issue with getting to the back side of the casing, because you simply rotate the casing around to the front side and keep welding. It's very nice to be able to turn that casing. Here's a good scene that shows the space requirement, or the footprint, if you will, of the DR drill rig advancing 24-inch diameter casing. The drill rig, the welder, the service truck, and the pipe had been laid out behind from, using a forklift and off of a trailer. And then the key component is this cyclone, and it can be set 60 feet away from the drill rig. But the thing about it is that you can control your cuttings. You don't have a mess underfoot where you're drilling. That is certainly appreciated, and I like it because I can catch the samples out here on this end, and so on. The most recent project that we were doing with this particular drill rig, just in October of 2020, was a well to be drilled and advance 12-inch diameter casing to a depth. I think this one went to close to 300 feet. But you can see the setup, and the cyclone was set up here. And during the time that we were drilling, at one time we were going through some very muddy brown material, a high percentage of fines. Later on the drilling of the project, we went through a lot of volcanics, so we had a lot of fractured basalt rocks and black and turned the cuttings gray. And then one zone we went through could have been a paleo soil zone that a very rusty red. It also could have been a fault zone that we drilled through, but we just kept drilling. But as soon as you drill through it, this is what you see in your hand or in the sieve or in the strainer that you use for doing it. And while you're drilling, every time you start the air compressor back up again, start circulation going again to advance another casing, you get a very good indication of how much water you're producing just through the bottom of the casing that you're advancing. Because if you are in the water table condition, while you're that hour or so while you're shut down and welding the casing together, that borehole is going to recover up inside the casing, so you're going to push that water out. And the amount of water that you push out every time you start up a new joint just gives you a very good indication of how much water and how good a formation you're in. If you can see in this slide on the right, there's an elevation difference between the foreground where we drilled the well and the background back there, which we estimated to be about 60 feet lower than where we were drilling. The client asked to have the well drilled up here on this old river bench. This is the Colorado River in the background over there. But this old river terrace is where they wanted the well drilled, and 60 feet is not an environment where a normal conventional air or mud rotary rig could start off with a 20-foot surface casing and go on down. It might even be difficult for them to get in a 60-foot piece or 70-foot piece of surface casing in order to not have a blowout, while drilling through that zone so close to the embankment. It was only about 10 feet to the embankment. But that's not the end of it with a DR rig. There's a lot more you can do with it, such as setting the pump, because the back end of it is typically open the way we work it. Once all the casing is in the ground and the well has been developed, it's quite easy to simply run pump with the thing. In this case, we were running a 40-horse submersible 6 or 8 inch pump on 6-inch drop pipe. And the well here, my job at the end of that project was to pump test the well and determine, yes, it was a 500 gallon a minute well with 20 feet of drawdown. You can also see in this slide the difference in elevation between the background, how far down, what the difference in elevation was on those two. But this well was made in 1 week's time. And I think that was quite a good achievement with that drill rig. So in summary, I'd just like to say some things about it. There's a lot of uses for DR rigs, depending on the markets that you can tap into. Air shafts and utility access shafts in hard rock and around hard rock mines or anything like that. Dewatering wells in hard rock mines or anywhere, bridge, road crossings and so on. They're very good for deepening existing wells. Elevator hydraulic cylinder shafts have been a market for some DR rig operators over the years. Those 3 or 4 story hydraulic elevators, you typically have a cavity down there to set the hydraulic cylinder in. And any other job that you can think of where you can plant steel pipe. I mean, even planting it for soil stability or terrain management or anything. Or if you want to just plant pipe and perforate it in place, there's a lot of different things that can be done with that. So the casing advancement drilling method, I call it a high-speed cable tool. You can do conventional air and mud rotary drilling just as well. If you equip it for reverse circulation drilling with a dual wall pipe, it's a far more beneficial tool than anything you've probably worked with in the past. You can even flood or reverse circulate this thing with a dual wall pipe by keeping the casing full of water as you're advancing it. if that's necessary. Planting steel pipe in the ground, I've mentioned that, permanent or temporarily, that's a very good reason to have one. Relatively small footprint and excellent control of the cuttings, excellent sample collection for both soil and the water and so on. And variable completions. You're not limited to just open borehole and sand pack and gravel grout up a well. You can use the telescoping screens. You can pull it back with a partial construction, or you can perforate it in place with no pullback at all. There's so many options that you can have with the DR rig. But that is my presentation. As I say, I'm not a salesman for the company. I just think they're a phenomenal piece of equipment. I've enjoyed working with them and around them, and I'd be happy to answer any questions that anybody might have about them. And here's my website where you can reach me and send me a question, and I'll try to help you out or get you some additional experience on a DR rig. Well, thank you very much for watching, and I hope you enjoy the rest of the Washington State Groundwater Conference. Bye now.